How's it going, everyone? Welcome. Eulier Gonzalez here. So today I want to look at how to set up a serverless because quite honestly, I don't know how to do that. And well, I'm about to work here using that tech on the company that I'm working on. And let's get into this. So in the next half an hour, I'm going to set up a basic serverless and run locally to see how that thing work. All right. So it means that uh, I'll later on switch to that code. So what is a serverless, right? Here's the quick start from serverless, which is this library, or according to the about section, is the effortless build app that auto scale incurs zero cost when idle and require minimal maintenance using AWS Lambda and other managed cloud service. So in other words, is that you can now create your own application, whether it's front end, back end, database, I don't care. Any applications. Instead of you hosting that in your with your own physical machines and having to manage security updates or OS patches, or even scale your instance to run now multiple processes or use more RAM or handle now is the increasing traffic in your app. Let's say, well, your app is something that users show a lot of interest. Okay, so that's something that is going to be take care of you when you hosting on a cloud server, whether it's AWS, all right, or other managed cloud services. In here is describing is Google Cloud Functions or Azure Functions. So not only that, you are now giving up your as a company, you are giving up all of your secrets and private data or computational power to process certain things to these top tech companies. Why is that? Because at the end of the day, they have now used all of the research to optimize its operations. And I want to hit the brake here real quick because when you're starting to recognize what these top tech companies are doing, you can also apply that to your life, right? So identify what are the areas in your life that you want to not spend time with that. For example, is cooking or do the laundry, right? So find ways to actually is get the same outcome with with the less amount of time, right? So this is just something that I also apply to in my case. But in having said that, here I am. Okay, now exploring is what this things is all about. But but be practical, right? So quick start. Here's how to install the serverless framework, set up a project, and deploy it to Amazon Web Services on serverless infrastructures like AWS Lambda, AWS Dynamo, AWS 3, and more. So in other words, what it's doing here, what it's saying is, I'm going to deploy my project is on the Amazon infrastructures, on the serverless infrastructures, okay? Uh, Whether it's the Lambda with the Lambda function, whether it is functions that I want to execute, or data that I want to store, or any other asset that I want to store, all right? And this is the main use cases for this. So install the serverless framework via npm, right? First, you must have the Node.js runtime installed, version 18 or greater, then you can install the serverless framework via npm. So then let's go to do this. Open your CLI and run the command below to install the serverless framework globally. Where is our terminal, right? Terminal, right? There you got it. Okie dokie, right? Good. I am on the I'm gonna put it here. Okay, so I am right now on my Vico app, which is something that I want to do that. Uh, but instead of the Vico, I just want to create now, okay, access to the tests, right? In here, I have several things running right now. But the only thing that is relevant is that I want to install is serverless globally. All right. It say all versions of Glob are not supported and may contain widely publicized security vulnerabilities, which may have fixed in the current version. Please update to support for older versions by contacting ISME and this one. So let me see what is the current now version, by the way, that I'm using here. I mean, sorry. on Node.js, right? What is the current version? I think they are on the 24 or something like that. Get Node 24. That's right. And it say that at least you should use is the version 18. So let's go with the second more stable version of it, right? Let me switch to this, and in order to do that, I already have now some Node manager versions known as NVM that I can list all the versions that I'm currently using, and I want to upgrade to NVM 22. Yeah, it's gonna use that. Install LTS JUT, right? That latest version. Okay, install the binary here. So download them and then install. Download them and see if they actually match the signature, what you download. And if it is, all right, good. Now, then it's gonna see. Let me actually flip to that version by saying, hey, use that current version. Let me first do something here. How can I remove here? Okay, man, help. NVM. Really? There's no man for NVM? Okay, anyway. But a couple example here is to remove, right? Once to is get rid of that. NVN on install. Okay, NVN on install. The other versions that I don't want to use any longer, right? So for example, is version 18, 12. So is this one, for example, or I will keep that around. The only version that I don't want to use is this. This version 2019 for sure. Okay, so version 2019, I don't want to use them. So free space from that. Okay, NVN list. I don't want to use this another version, so release those binaries. So NVN no version manager on install this another version, right? So now I'm using is the version 22.22.2. Okay, got it. And there are some other version managers here, right? Whether it is the NVN, the FNN. This is something that I think this is quite new, by the way. I am not used to that, but this is how you can use, right? So okay, got it. And also let me look at the npm version. Using is the 10 version. Okay, got it. Cool. Now So let me is uninstall this globally. All right. Don't you support that? Okay. Uninstall. I think is remove. That's right. And let me now is install that. Okay. Got it. Cool. So, run serverless to verify your installation is working. So if I run this command, serverless, the name can be quite deceiving. Is a updating, so it seems that we already downloaded and installed that properly. Install serverless framework, and here we are. Okay. So what the French is it? Select a template. Here we are. Create a new project by selecting a template. Welcome to the serverless framework v.4. Create a new project by selecting a template to generate scaffolding for a specific use case. So most of the time, this is the most common use cases. Hey, I want to use Node with HTTP or an Express with HTTP or Express API with Dynamo and schedule task, simple functions, Python, interesting. Whether it is as a simple HTTP or a Flask API with Dynamo, schedule task, simple function. What if this is not what I want? You know what I mean? What if I want something else? Right? So what if I want to go with something else? Right? Compose serverless plus CloudFormation plus SAM. That's interesting. So let's go with this one, which is something that I'm quite familiar with, right? With this most common sample. So you have an HTTP, you have an HTTP server that store data on a database using Node.js, right? Let's get into this. Let's say name your project. And that's interesting because my question is, now that I'm running this, and you are giving me couple templates that I can generate code from it, okay? So the primary concept for a project in the serverless, okay. So now that I run this, the other is a serverless command. The serverless framework shipped with a serverless command that walks you through getting a project created and deployed onto AWS. It helps with downloading a template, setting up the AWS credentials, setting up the serverless framework dashboard, and more, while explaining each concept along the way. This guide will also walk you through getting started with the serverless framework, but please note, simply typing the serverless command may be the superior experience. Okay. So in other words, it's like a wizard, right? It's holding your hands along the way until you get to the kindergarten. But in this case, it's like holding the grandma or it's like holding the grandma or grandpa hands to help them cross the street. Okay. But in this case, is to, well, setting the projects and deploy it onto AWS. So here's the thing. Create a service. The primary concept for a project in serverless framework is known as a service. And it is declared by the serverless file, which contains simplified syntax for deploying cloud infrastructure, such as AWS Lambda functions, infrastructure that triggers those functions with event, An additional infrastructure your AWS Lambda function may need for various use cases. So, for example, to catch some data using Redis in memory, or to store some data in a relational database, whether it's Redshift, or store non-relational data, okay, uh, or any other asset, for example, image and videos, like using a S3 storage bucket, AWS API gateways for receiving HTTP requests and forwarding them to AWS Lambda. A service can entirely be an application, logic for any specific domains, blog user products, or microservice handling one task. You decide how to organize your project, and this is when things are now part of the software engineer, rather than the infrastructures as it is. So this is our goal here. This is what we are getting paid for, by the way. You decide how to organize your projects. Generally, we recommend starting with a monolithic approach to everything to reduce complexity, until breaking up logic is absolutely necessary. To create a fully set up serverless framework service, use the serverless command, which offers an interactive setup workflow, which is where I'm currently at, right? But the thing here is, it will show you several templates. Choose one fits the language and use case you want. But in my case, right, I tried to get into that, but you don't have the template that I want to, you know? You don't have the template that at least for GraphQL, for example, right? Yeah, at least for GraphQL. Why GraphQL? Because this is what we care at the end of the day. Okay, so after selecting a service template like this, its files will be downloaded, and you will have the opportunity to give your service a name like this, right? Please use only lowercase, lower letters, numbers, and hyphens. Also keep service names short, since they are added into the name of each cloud resource the serverless frameworks create. So in other words, because this will be deployed, please make it short. And some cloud resource has character length restriction in their name. And see more about the core concept. So as a serverless framework v4, if you're using the serverless command to set up a service, it will eventually ask you to log in. If you need to log in outside of that, run serverless login. Logging in will redirect you to serverless framework dashboard within your browser. After registering or logging, going back into your CLI, and you will be signed in. Please note that you can get up and running with the serverless framework CLI and the dashboard for free. And the CLI will always be free to small org and indie hackers. For more information on pricing, check out the pricing here. And then creating the app. The app concept is a parent container for one of the many services, which you can optionally set via the app property in your serverless YAML file. Setting an app also enables serverless framework dashboard features, so that service like tracking your service and their deployment in serverless framework dashboard, enabling sharing outputs between them, sharing secrets between them, and enabling metrics and trace and logs. If you're using the serverless onboarding command, it will help you to set up an app and add it to your service. So you can use the serverless command to create an app on an existing service as well, or create an app in the dashboard. And here's when it's asking the app: e-commerce, blog, admin, you name it. This app can also be set manually in the serverless YAML file here. Because right now, this, yeah. For real? Okay. So right now, exactly. This is just a service. Okay, there is no app concept involved, but you can have that, which is a padding concept for one or many services. Okay, so you can run now multiple services, uh, defining this file. Okay, setting up AWS credentials, and deploy a server. So in developing here. So let's do this. Let me create this small simple application here with a crew. I'm gonna call this bank service. Okay. So I've downloaded the template, and it says this template contains a serverless framework service are stack on of the AWS resource and can contain your entire application as part of it. User comment checkout. Enter the name using lower letter cases, numbers, and hyphen only. Serverless framework for CLI is free for developers and organizations making less than 2 million annually, but requires an account or a license. So that's a good question. What account require? Because if I say login a register or get a license, right? If I say get a license, it will take me to this and say, hey, even though you need to log in here. Okay, I'll pause the video and I'm gonna log in here. All right, and we're back, right? So I'm on the app Serverless, right? And as you can see, I have now certain metrics that is indicating me the health of this Lambda service, as well as some other additional metrics like invocations, successful, uncaught errors. You know, it's like a reporting tool. Pretty much is this, right? Invocation and events, how long has been, functions latency. So for example, some additional informations, right? So the amount of account if you have, or apps, which is a collection of service, if you have any service, or the stage, you know, additional data that you might want to use, right? And no, in CI/CD deployments. So if I go back to the here, right, on the sign-in process. So now that I get in here, right, I can log in and register. We say opening the web browser. That's great, right? I can say, hey, continue to dashboard, right? I already here, okay? And this is some additional information for defining the serverless file. So here is asking me this: create or select an existing app. Whether if I create a new app or skipping the adding an app like that. Let me create now a new app for that. Okay. So here you say, what is the new app? You say, hey, this is a banking. So banking app, right? Banking app, all right. Hey, AWS credential setup methods. create an AWS IAM role or sign into that, save the credential here or skip and save and set that later. Let me do that here. And it says your AWS IAM role will be stored in the Serverless provider. To get started, log into the AWS account if you wish to use a /serverless and go on the URL like this. The CLI will not wait for the AWS CloudFormation stack to be completed. It will automatically detect when this is done. Okay, so I'm going to authenticate with that. I'll be right back. Alright, so after I sign in, okay, using the URL that Serverless gave it to me. Now, here's the thing. It gives me is this quick create stack. What in the French toast does that mean, right? What is a stack and what is CloudFormation, right? So AWS CloudFormation model and provision all of your cloud infrastructure. AWS CloudFormation provide common language to describe a provision of all the infrastructure resource in your environment in a safe and repeatable way. Again, what in the French toast is this? Why do I even need
In this
to
video,
have this?
you'll see how to simplify your infrastructure management using AWS CloudFormation.
Okay, allegedly, right?
AWS CloudFormation is a service that allows you to create and manage a collection of Amazon Web Services resources based on a template. AWS CloudFormation
Okay, so it allows you to manage
a collection of is a service that allows you to create and manage a collection.
Okay, it's a service that allows you to create and manage a collection of the AWS servers
of Amazon Web Services resources based on a template. AWS CloudFormation enables orderly and predictable provisioning and updating of resources, as well as version control of your infrastructure.
Two things here. That's the two main benefit of this. So not only get your vendor login by AWS, but first you can now create and manage in an orderly way updates of your resource. And the other is to have a version control of it. Okay, so you can think of this like having a serverless stack, right? Where each of those stacks now represent, for example, is a particular resource, your database, your in-memory database to have data more closer to the CPU so you can process that faster, or your CPU, storage, right? But all of these resources, CloudFormations now allow you to create and manage all of these resources in an organized way, right? In a predictable way, and also it allows you to have now version control of your resource or your infrastructure. So what does it means? That is that, hey, this is the snapshot at this moment in time of your app, right? Of your infrastructure. So you can think of this like a snapshot of a city. Pick up the city that you like to. I don't know, Miami, Florida, Miami, or New York, or LA, San Francisco, Austin, Texas, El Paso, you name it, right? Buenos Aires, Ciudad de Mexico, Sao Paulo, Santiago, Bogota, you name it, you name it. You French toast, name it. And so yeah, okay, got it. All right, and so yeah, okay, it makes a lot of sense for this. Anytime that you hear about a version control, is you can think of this like a snapshot at that moment of your infrastructure, aka at that moment is when that city was back in the 70s, and then on the 75, and then on the 80s, and then on the 90s, 2000, but this is pretty much like what version control is all about. This is the summary of this. This series of snapshots that capture your infrastructure in this case at that moment. Why this is useful? Because we can roll back to a specific time when things work as expected. All right, that's the main benefit of using version control. And the other is that since you can create and manage AWS resources, it also allows you to do that in an orderly way. In an orderly and predictable way. AWS Cloud Formation.
Dating of resources, as well as version control of your infrastructure. AWS Cloud Formation allows you to model the resources you need for an application or solution in a text file.
Exactly. Holy moly. So this AWS, okay, so you're becoming now an architect here. Holy shit. So AWS Cloud Formation allows you to create and manage all of the resources that an application might need to. And model that. Okay.
Formatted in JSON or YAML.
Mm-hmm.
This template, which you can upload manually or retrieve from an S3 bucket, defines the collection of resources as a single unit called a stack. CloudFormation translates the template's parameters into API calls and creates the stack. It then provisions the stack's resources as a running environment. You can create, update, and delete stacks by using the AWS CloudFormation console, AWS API, or AWS Command Line Interface, or CLI. To get started with CloudFormation, let's navigate to the Stacks screen. Here you can see a list of stacks currently running in this region and the status of each one. You can view the stacks deployed in different regions by using the region selection menu.
Yep.
To find stacks faster, you can use the search bar to filter by stack name or keywords. You can also filter by status. For example, this view shows all your deleted stacks. You can use this view to verify that all stack resources have been removed from your account. This view shows stacks that have failed during deployment. This could indicate an issue with the stack template.
Wait,
For example, or by status.
Okay, provide status.
For example, this view shows all your deleted stacks. You can use this view to verify that all stack resources have been removed from your account. This view shows stacks that have failed during deployment. This could indicate an issue with the stack template or with your account configuration. Finally, this view shows stacks that have completed deployment successfully. Notice that some stacks in the list are labeled nested. These are stacks that were created as part of other stacks. You can use this toggle switch to exclude nested stacks and show only root stacks. You can select a stack and perform certain actions on it. For instance, you can enable termination protection for your business-critical stacks to prevent them from being deleted accidentally. You can also perform other advanced tasks, such as managing drift, creating change sets, and importing resources into a stack. When you are ready to begin deploying resources using CloudFormation, you can create a new stack. In this case, let's create a stack with new resources. The first step is to specify which template to use. You can specify an existing CloudFormation template by providing an S3 URL, or you can upload a template file manually. In this case, we'll upload a sample template. Let's select a simple LAMP stack template. Step 2 is to specify stack details. First, enter a stack name. Depending on the stack configuration, you might also need to provide custom parameter values that are used during stack deployment. In this example, passwords and a username are needed for the MySQL database resource in the stack. An existing key pair is also required to enable Secure Shell or SSH access to an Amazon Elastic Compute Cloud or EC2 instance. Once you have provided the required stack details, proceed to the next step. In step 3, you can configure additional stack options, such as tags, permissions, and advanced options. For the purposes of this example, let's leave everything as is and proceed to step 4. This screen allows you to review the entire stack configuration and make edits before you create it. When you're ready, click the button to create the stack. Once the deployment has initiated, a screen for the new stack appears. In the Events detail pane, you can track the status of operations as the stack is created. In the Stacks pane to the left, you can quickly switch between details for other stacks without having to navigate back to the main Stacks screen. To better view the stack details, you can collapse the CloudFormation navigation pane. Notice that there are new events available. Let's refresh the view to see them. The top event shown here indicates that the stack deployment is now complete. In many of the stack detail panes, you can customize which columns are visible. Click the gear icon to specify your preferences. Let's show the type column. Now you can see the AWS resource type associated with each event. Next, let's quickly review some of the other detail panes available for a stack. Stack Info displays general information about the stack and its configuration. Resources displays the resources that are part of the stack. Outputs displays outputs that were declared in the stack's template. For example, here we see an output for the URL of a website that was deployed as part of the stack. Parameters displays the stack's parameters and their values. Template displays the stack's template, allowing you to review the code that was used to create the stack. Next, let's look at stack sets. AWS CloudFormation Stack Sets extends the functionality of stacks by enabling you to create, update, or delete stacks across multiple accounts and regions with a single operation. With stack sets, you can easily scale out your CloudFormation deployments throughout an AWS organization. You can view stack sets information just like you can for a single stack. For example, the Stack Set Info detail pane displays general information about the stack set and its configuration. Stack Instances displays all the AWS accounts and regions this stack set has been deployed to. Operations displays the results of any operations you have performed, such as creating, updating, or deleting the stack set. Parameters displays the stack set's parameters and their values. Template displays the template for the stack set, allowing you to review the code that was used to create this stack set. Next, let's navigate to the Exports screen. To share information between stacks, you can export a stack's output values. Other stacks that are in the same AWS account and region can import the exported values. For example, you might have a single networking stack that exports the IDs of a subnet and security group for public web users. To help improve the CloudFormation service, you can leave feedback at any time. We value your input. You've just seen how to simplify your infrastructure management using AWS CloudFormation. Thanks for watching. Now it's your turn to try.
Absolutely. That's what I'm doing here. So this is the idea behind that, right? AWS CloudFormation explained. Got it. So this allowed me is to create and manage a collections of AWS services. uh, and having a version control of this. So in other words, I can define is I can model is the all the resources that an application needs, and then take a snapshot of those when they works in a desired state, in a specific version. That is mind bending, and that's exactly what I'm doing here, right? It's say, hey, let's going to create now a stack here, right? And it say, hey, view the templates here. So this is the template that the serverless is about to create, right? This stack creates an IAM role that can be used by a serverless framework for using in deployment. So not only that, here I'm defining is this IAM identity as a YAML file, okay, which describing is what is the resource, an ID, who is the type of role, okay, and what are the effects that these roles can have on a principle or in a collections of uh, resources, in this case this IAM, and what they can do, which is the actions here, and some of additional conditions for, right, reported function types, outputs, yada yada yada. And they say, hey, this is the provide stack name. I'll go with this default one. Some parameters are defined in your template and allow you to input custom value when you create or update your stack, okay. So this is the default, the or URI and role name, right? Some tags, permissions, stack failure options, rollback all stack resource, and use deletion policies. Okay, stack policy, rollback configuration, notification options, stack creations options. But all of this is just creating is this role, all right. This is a very programming thing, you know. It's saying, hey, the following resource require capability of the IAM role here. So in other words, I am creating this role which is specific to AWS that allow me to identify this resource on AWS to have access to something, right? So in our case, the actions that it can have, right, is allow, right? Yeah, is allow here. So I acknowledge that AWS Cloud Formation might create an IAM resource with custom name. Right, the following resource require capability for that. The template contains identity access management research, and check that you want to create each of these resource, and they have a minimum requirement permissions. In addition, they have custom name. Check the custom name are unique with your AWS account. So when I create a stack here, right, it's gonna take some amount of time. This stack that is creating is just in this case is for the role, right? Okay. And when I go back to the terminal, right, I'm waiting for AWS Cloud Formation here. Your new service, bank service, is ready. Here's a new step. Open service directory, cd bank, install dependency, npm install, or use another package manager, and deploy your services using the serverless deploy, right? So what this thing does is just to create that. So not only that it create is not only that it create is the role for managing this function, right? They create complete and create in process, okay? custom serverless functions reported, right? But now that I can get into that, say cd bank, diggy, open this with code. I know that a lot of people love to use cursor because that is quite cool, but in my case, I don't want to do that. I am deliberate not to do that because I want to explore the code base here by my own, right? So this is what this create. This was generate, right? It generates is a basic okay. Got it. It generate is a basic. That's lovely, but no thanks. A basic using a Dynamo client DB. So it create now a basic application using Express and also using is this old versions of Node.js, which is CommonJS. File in a CommonJS, it may be converted to an ESM. Yep, absolutely. That's now the convention of using JavaScript here. And here is actually pulling some of the command from Dynamo, the web server, the HTTP server using a serverless, the application using Express to build our web service. Okay, some of this basic static data that you have. So for example, process.m, the user table. Here there is nothing like that. The client is created the DynamoDB client, CTT. So it's actually creating the instance object from Dynamo to connect to. It's starting to add in the middlewares to that. Then it say, hey, let me is define a couple, or in this case, only two endpoints. One of them is the users, right, to get only one user. All right, and what it does is to check that, so define these particular objects and then trying this async operation, right? By getting the command, I already create another Dynamo Insta clients, and then now call that client and send that command here, right? So what this thing is doing is just passing the parameter for the get command that will talk to the DynamoDB. It will give you now, after an X amount of time, the data, all right, as an item. And if the item exists, okay, so let's go to now respond back to the server. If it's not, hey, well, there is an error, right? This is if this actually works, right? This is if this actually works. But if it's not, well, throw an arrow with 500 because I don't know what's happening here, right? This pattern here, this sequence of defining the routes and then the handlers, and inside of the handler is the business logic. In our case, is just to defining the parameters for this functions that is going to do the database operations. In our case, read the database. And once we already have the command, it say, hey, let me now actually run the command or send this command using now the client that already created that, right? And then, well, actually check, hey, do I have the data? If it is, good. Let's respond with this. If it's not, let's respond with that. In this case, the 404. And if there is some errors, all right, when I try to read this data and the error and the server fail, well, I want to not only throw this but capture into some error logging. Okay, so that's great, because now that I do have this app.post, which is the user, is quite the same, right? In this case, what it's gonna read is just the data. It's gonna perform some checks here. If the data exists, let's going to do some early errors detection. All right. If it's not, I mean, if it's exactly if the data does not exist, or if you don't give me in the proper format, I'm doing this early validation. Okay, before actually processing that data. And again, it's going to put this command, send that, and repeat the process. So this actually is this basic application, right? Pretty simple, pretty straightforward, nothing too fancy, right? It was using is that, like this deployment install dependency with this, npm install serverless deploy, deploying AWS Now Express Dynamo here. Okay, so this is how you can install your dependency for this and then deploy that. After running deploy, you should see the output similar to this, AWS Now Express Dynamo API to stage def on this region, service deployed to stack, AWS Now Express Dynamo API def, and the endpoint, which is any random name that they give it to you, execute API, the region followed by the name of the cloud provider that can, and the name of the function here, right? So if you take a look at the serverless, which indicates is the service, you can define the app that allow you to have multiple services running here, some of the stages, the providers, okay, hey, where are you gonna run, and what are the things that it needs to, hey, I do have this identity role, that this is all the things that I need to have access to, right? AKA run some crew command, create, read, update, and delete, right? The environments, user tables here, environment variables here. That's interesting. So this is injecting these environment variables at runtime, and some of the function and the resource that it use. Okay, got it. So pretty straightforward. We're using now the serverless, but HTTP, okay, as a dependency. And all I want to do right now is, well, if I run this, so how can I run this? Because how do I run now this locally? That's the whole question. That's the whole question. That's the whole question here, right? That's the whole question. Okay, this is how you can create an app. Setting the AWS credential, I already did that. Deploy a service, I'm not gonna do that. But I want to develop this. Many serverless framework and serverless developers generally choose to develop on the cloud, since it matches reality. It is your production environments and emulating Lambda and other infrastructures dependency locally. Okay. And emulating Lambda and other infrastructures dependency locally can be complex. Merchants of complexity, man. In Serverless Framework v.4, we have created a hybrid approach to development to help developers develop rapidly with the accuracy of real cloud environments. This is the new def command, When you run this command, the following happens. Question: do we have this command? Which version I'm running it? Okay. Exactly. Do I have that command? Mm-hmm. Mm-hmm. Okay. Ah, I get it. Ah, these motherfuckers. I get. Okay. Uh huh. Mm-hmm. 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 Okay. Okay, got it. Okay. And what happened is that they're using this GraphQL because now you can, based on a single endpoint, handle several logic here. The holy hell. Okay. So this is the serverless def command. So when you run this command, the following happen. AWS CloudFormation deployment will happen to slightly modify all the AWS Lambda function within your service so that they include a lightweight wrapper. Once disable the AWS CloudFormation deployment has completed, your live AWS Lambda function within your service will be still able to receive events and be invoked within AWS. However, the event will be secure and instantly proxy down to your machine. And the code on your machine will be run rather than the code within your live AWS Lambda function. So what they're doing is to proxy down into my machine all of these events. This allows you to make changes to your code without having to deploy or recreate every aspect of your architecture locally, allowing you to develop rapidly. Logs from your local code will also be shown within your terminal dev season. Once your code has finished, the response from your local code will be forwarded back up to your live AWS Lambda function, and they will be returned once your code has finished. The response from your local code will be forwarded back to your live AWS Lambda functions, and they will be returned the response just like a normal AWS Lambda function in the cloud will. Please note dev is only designed for developing or personal stage environment and should not be run in production or any stage where high volume of events are being processed. Once you are finished with your dev season, you must redeploy using serverless deploy to push your recent local changes back to your live AWS Lambda functions. And your AWS Lambda function will fail. Or your AWS Lambda function will fail. So in other words, what this thing is doing is, hey, I'm going to now um, develop once. So I'm going to now deployment. So I'm gonna deploy. To the AWS Lambda function within your service so that it includes a lightweight wrapper. So once this AWS CloudFormation deployment has completed, your live AWS Lambda function with your service will still be able to receive and be invoked within AWS. However, the events will be securely and instantiated proxy down to your machines, and the code on your machines will run, which will be run rather than the code within your live AWS Lambda. But it's so an AWS CloudFormation deploy will happen to slightly modify all the AWS Lambda. An AWS CloudFormation deployment will happen. So not only that you're going to deploy to AWS CloudFormation with a Lambda function, so that they include the lightweight wrapper. So you're going to deploy to the Lambda function with a wrapper, with a lightweight wrapper, and once that is done, your live AWS Lambda functions within your servers will be able to receive event and be invoked by the AWS. But instead of those being processed there, they will be proxy down to your machine. Holy hell. They will be proxy down to my machine, which is authenticating with the AWS credentials, loading the services, right? Retrieving AWS CloudFormation stack. Your local machine is using no version 22, while at least one of your functions is not. Ensure matching runtime versions to accurate testing. While at least one of your functions is not. Ensure matching runtime versions to accurate testing. There you, okay. Okay. 22-ish. So if I run that again, there you got it. Run serverless deploy after a dev mode season to restore original code. It's now uploading to the AWS CloudFormation, and it say, hey, there's some fucking error here. It's in create in progress state and cannot be updated. Wait, what? Error with this AWS CloudFormation in the US 1. It's in create process state and cannot be updated. Okay, holy hell. Debug. To show me all the logs here. Update in progress. Okay. Update complete. AWS Lambda functions API, like that. Connected. Okay. Saving meta record to global.serverless directory. So I am connected. So the question is, how can I run that locally, bro? You know, to invoke your AWS Lambda functions on the cloud, you can find the URLs for this and deploy an Steam log, full local development. Many serverless framework users choose to emulate their entire serverless architecture locally. Please note, emulating AWS Lambda and other cloud services is never accurate, and the process can be complex. That's what happened. And the process can be complex. Okay? So trying to emulate your AWS architecture here locally, it can be complex. Please know, emulating AWS Lambda and other cloud services is never accurate, and the process can be complex, especially as your project and team grows and teammate grows. At version 4, we highly recommend using is the new dev mode with personal stage. If you do choose to develop locally, we recommend the following workflow. Use the invoke local command to invoke your function locally, like this. You can also pass data to this local invocation via a variety of ways. Here's one of them. And more details on the invoke local command can be found here. Serverless Framework also has a great plugin that allows you to run a server locally and emulate AWS API Gateway. This is the serverless offline command. More detail on the serverless offline here. So, okay. And finally, to what I really care about. Serverless offline. Okay, and this was created by, okay, holy moly, Helsinki, Finland. Okay, got it. Holy moly, okay. Cactus Systems, energy but better. Helsinki. Okay. Interesting. Very, very interesting. Okay, so oh my god. Okay, it's because they have that kind of problems, bro. We're looking for maintainers. Please contact the Heraut if you feel you are a good match. Serverless Offline is supported by the community. Special thanks to our code, the first role-playing game for developers. XP levels ups and guilds, all while you work. These serverless plugins emulate AWS plugins here. AWS Lambda and API gateways on your local machine to speed up your development cycle. To do so, it starts an HTTP server that handles the request lifecycle like APGA does and invokes your handlers. So this is all of the frameworks or runtime that you can use, right? Velocity template support, lazy loading on your handler files, and more. Integrations authorizers, proxy timeouts, response parameters, HTTPS cores, etc. This plugin is updated by its user. I just do maintenance and ensure that PRs are relevant to the community. In other words, if you find a bug or want a new feature, please help us becoming one of the contributors and see ya. This is what this allows to. It only allows you to run is AWS Lambda and API Gateway. My question is that what is the API Gateway? You know what I mean? What is the API Gateway? Create, maintain, and secure API at any scale. Can you elaborate more about this? Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitoring, and secure APIs at any scale. APIs act as the front door for applications to access data, business logic, or functionality from your backend services. Using API Gateway, you can create RESTful APIs and WebSockets that enable real-time two-way communication applications. API Gateway supports containerized and serverless workload as well as web applications. API Gateway offers portals that enable you to create fully managed and AWS native developers portals for your APIs. API Gateways offer portals that enable you to create fully managed AWS native developers portals for your APIs. They, the marketing team, Jesus fuck, the marketing and the copywriter, Jesus, they love to use sound breaking. They love to use this hard taking or breathtaking. You know, they love to use this overcomplicate linguistic gymnastics. Yeah, they love to use. They love to do linguistic gymnastics. That's what it is, man. Linguistic gymnastics. Why you don't tell me what this is in few words, bro? API gateways offer portals that enable you to create fully managed AWS native developer portal for your application. In other words, so they offer you this product so you can develop APIs on their AWS, on their service. With API gateway portals, you can centrally discover, document, and govern your REST API across your AWS infrastructure. API Gateway handles all the tasks involved in accepting and processing your up to hundreds and thousands of concurring APIs, concurring API calls, including traffic management, core supports, authorization and access control, throttling, monitoring, and API version management. API Gateway has no minimum fees or startup costs. You pay for the API calls you receive and the amount of data transferred out, and with the API Gateway tiered pricing model, you can reduce the cost of your API use scale. Build REST API and optimize for serverless workload and HTTP backend using HTTP APIs are the best choice for building APIs that only require API proxy functionality. If your API require API proxy functionality and API management features in a single solution. API Gateway also offers REST APIs. Wireless car. Learn how to connect mobility providers, wireless car, enhance startups performing using AWS Lambda, Snapstar for Java, Odyssey Interactive, Betterfly. Learn how Betterfly simplifies group protections and benefit management and encourage daily positive habits using digital solution. Devo. Okay, so so API Gateway, all right, allow you to define is API. So it allows you to create, publish, maintain, and monitoring and secure APIs. Okay. And the other is the AWS Lambda functions. AWS Lambda empower you. Lambda functions. Run code without thinking about servers or clusters. So in other words, you will run this particular code or logic for this real-time data processing, batch data processing, and interactive web and mobile backends. So here's the thing. They're combining is two concepts here. They're combining is the Lambda and the API Gateway. All right. One is for data processing, usually here, right? Data processing here, and the other is for exposing this resource using an API, where you can create, publish, deploy, uh, monitor, and secure APIs at any scale, right? Look, this is the promise. This is the promise. And if you want to develop that locally to speed up things, and you do this. Okay. 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 So this is the installation. First, add the serverless offline to your project. Then inside of your project serverless.yml file, add the following entry to the plugin section, serverless offline. If there is no plugin section, you will need to add it to your file. Note that the plugin section to serverless offline must be at the root level on your serverless YAML file. It should look something like this. You can check whether you have successfully installed the plugin by running the serverless command here, serverless verbose. The console should display offline as one of the plugins now available in the service projects. So let's go to install this, right? Let's get into that. Okay. So now that I install is the serverless, I'm going to install now is the serverless offline to develop applications on the cloud locally. Try to replicate the production environment is quite hard. So here we're only locally replicating is Lambda functions for do some backend processing data batching, processing data and so on and so forth. And the other is the okay, and let's also add this the plugin here, right? So you find here plugins. There is no plugin, so you need to add that at the top. So the resource you got here, the plugin serverless, right? And if you're trying to run this serverless verbose, right? Welcome to the serverless framework. This is the serverless framework. Let's do some quick check to ensure is everything is correct. Your serverless framework service is ready to deploy. So the console should display offline as one of your plugins, as one of the plugins now available in your serverless project. Remember to put this. Note that the plugin section for serverless offline must be at the root of the serverless YAML file. Must be at the root of that, which is at the root, right? It is at the root. So if your project, in your project root serverless offline or this one. So if you run this serverless offline, now I can develop this Lambda functions and APIs locally. Okay. Which version am I currently using it? I'm using it the 14.5, bro. I'm using it a 14.5, bro. And here is using it a 13.9. Okay. Got it. Okay. so now if I hit those functions, so for example the users with some random ID, right? Which is, let me go to localhost here and then say, hey, I couldn't find this route because that doesn't exist. If I say one, it's return me that because you say, hey, no, not found, that's right, right? And if I now send something as a post, I can do that as well, right? But again, now this is working as expected, but I'm developing this locally. All right, that's the TLDR of this serverless and all of these different concepts involved. Cloud formation, which allow you to create is a collections of services, a collections of resources that are relevant for these applications. So, for example, um, if you're building a web app for doing some crew operations, you say, hey, I need to have the server, the database, and also build the front end as well. So AWS Cloud Formations allow you to cover for these solutions. Mm-hmm. And okay, holy moly. Okay, and and here you got, right? I got the bank service, right? As part of my stack here. You can see what this stack is defined. This is the resource. Yeah, this is made of the Lambda functions and the API gateway, right? Some additional things that might need to, for example, route, stage, and of course is the IAM role and the dynamo table, right? Like the user tables. Right now, this doesn't have any tables, so this table doesn't have any rows, so it's empty, right? So yeah, warm throughput, reads unit per second to 12,000. Okay. So this is now DynamoDB, Cloud Formation, right? And here, I just want to summarize this. So this is the service that I'm creating for this particular solution. For example, this small banking app, right? The database, the roles that I need to assign to this stack to say, hey, this application, this API can run in AWS, right? And this API is made of the API gateway here, the stage, right? The routing, some additional resource like integration as well as the API, where this is located, right? And the logs from this. And also is the Lambda service, right? In the Lambda version here. So here, if I go here, it will take me to the Lambda version here. That's right. Back service dev API. There you got it. And I can actually develop this application locally. Holy moly. Holy moly, I can develop this shit locally. There you got it. Okay, but this is what is being deployed. Okay, this is what is being deployed to this. That's interesting. That's interesting. What is being deployed to this? The test, the monitor, the configurations, aliases, versions, monitor, code. Okay, makes a ton of sense. Exactly. So the API gateway, which just act as the front end, right? This is what is going to expose. This is the endpoint here, right? And this is what is going to be processed here. Okay, so this API gateway now uh, manage this, or is capable of doing this. All right. Okay. Good. Good. Holy moly. So that'll be all for this video. Take care. Bye bye.